But on here, the front side of the notes is going over interior angle sum, so that's like adding up the total of the inside of these shapes. And then on the back side, it is the exterior angle sum, which is obviously the outside, so it's adding up all the angles on the outside. So on this front side, first thing I'm actually going to start with is going to be these shapes over here. These aren't on your notes, but if you want to draw them, cool. If you want to just watch as I do it, I don't particularly care either way. But when you're looking at these shapes, there's a few things that I want to look for. So first thing I want to figure out is how many sides there are to the shape. Okay, so obviously if I'm looking at this shape, there are 3 sides to this shape. Okay, then I'm going to figure out how many triangles could I make in that shape by connecting diagonals. And what that means, when you connect a diagonal, that means you have to connect just the vertices to one another, right? Now, if I look at this shape, there's no way for me to connect these angles at the end with a straight line, right? Without just obviously drawing the outside edges, right? I can't do anything like this, right? That's not a straight line. Okay, so I can't connect the diagonals, which means I can only make the one triangle that's in here. So I'm just going to write on here, 1 triangle. And then I just need to write what is the total of all the angles, right? Well, if it's 1 triangle, what's the total of angles for a triangle? What's the total angles of a triangle? 180. There are 3 angles, but yes. It totals up to 180 degrees, right? So this is 180 degrees, right? Those are the 3 things I'm looking at for each of these shapes. How many sides, how many triangles, and 180 degrees is the total of that shape, okay? So keeping that in mind, if I look at the next shape, how many sides are there on that shape? 4, right? That shouldn't be too terribly hard. So it's got 4 sides. Now, by drawing diagonals, right? And again, diagonals connect these corners of the shape. Okay? And the key when you're drawing the diagonal and thinking about that is they cannot cross each other, right? You can't intersect, which means I can't draw like this and just draw 2 that cross each other. When I draw the diagonal, it has to be that once I draw this diagonal, if I was to draw another one, it can't cross through it, which means I can't draw another one, because if I was to do this way, it's going to cross it right there, which means that doesn't work. Okay, I could just redraw this and put it this way. It doesn't really matter which way I draw it. Okay, but if I draw a diagonal, I can only draw the one without drawing another one that crosses through it. So how many triangles did that make when I drew that one diagonal? 2, right? So this shape has 2 triangles. Okay, now how many degrees are there in each triangle? 180, right? So this is 180. This is 180. So if I asked you then, what's the total degree for a square, how could you figure that out? I can add them together, right? So 180 plus 180, what else could I do instead of adding those 2 things together? Not divide them. Multiply by 2, right? Since there's 2 of them, I could just do times 2. So what do I get when I do that? 360, right? So a square is 360 degrees. Okay? So it's got 4 sides. It makes 2 triangles when I draw the diagonal in there. 360 degrees. Okay? Now, this last shape that I'm going to do, what is that shape called? Anyone know? Huh? Not a quadrilateral. Quad means 4. This is not a parallelogram. It's a pentagon. Y'all learned shapes in like 2nd grade. Okay, it is a pentagon, which means it has how many sides? It has 5 sides, right? So this has 5 sides. Now, here's where drawing the diagonals might be a little confusing. Okay, if I draw diagonals, remember that's connecting like all these corners of the shape. Okay, so if I was to draw diagonals, I could draw one from like here to here. That would be 1. Now, if I want to draw another diagonal, well, remember, I can't let it cross through. So what I can't do is draw one like this where it crosses through it, right? That does not work. So I can't draw one there, but I could draw one maybe going horizontal like this, right? How many triangles would that be then if I did that? That'd be 3. And maybe I'm like, okay, wait, maybe I don't want that one. Maybe I wanted to draw one here. Change it up. How many triangles is that? Still 3. No matter what I do, no matter how I change these around, without crossing through one of these, no matter what I do with this shape, it can only make 3 triangles with the diagonals. Right? So no matter what I do, however I arrange these diagonals, there's no possible way for me to move them around to where it makes more than 3. Right? So that means for this shape, there are 3 triangles. Okay? So now knowing that, each triangle, as we've said before, is 180 degrees. So how could I figure out the total degree of that pentagon? 180 times the 3 triangles, right? Because each triangle is 180, so obviously if I just multiply by 3, that would give me my answer, which means it is 540 degrees. Okay? Now, by looking at these, if I'm just really focusing in on the sides and the number of triangles, what do you notice about these when you compare just the number of sides to the number of triangles? So the first one is 3 sides, 1 triangle, then 4 sides, 2 triangles, then 5 sides, 3 triangles. So what do you notice when you compare sides to triangles for all 3 of those shapes? Right, it's however many triangles there are, the sides is just 2 more than that, right? Or if I go backwards, however many sides there are, I just subtract 2, and that tells me how many triangles there are, right? Because for 3 sides, it was 1 triangle. 3 minus 2 is 1. 4 sides, 2 triangles. 4 minus 2 is 2. 5 sides, 3 triangles. 5 minus 2 is 3, right? So when you're trying to find the total degree of a shape, all you have to do is figure out how many sides there are. Once you know how many sides there are, that tells you how many triangles you can make with that shape. And once you know how many triangles there are, you already know a triangle is 180 degrees, so you just multiply by however many triangles it can make, and that gives you the total. That is actually what that polygon interior angle sum theorem, that's how they created that equation right here. Right? N minus 2 times 180 is what we just kind of came up with, right? The number of sides minus 2, that would tell you how many triangles there are, times 180. Okay? That is the equation or expression that you would need to know for this section, right? It's just however many sides, take away 2, and multiply by 180. Okay? So like for example, they give you this one here. This polygon has 13 sides. So all they did was say, okay, 13 sides, so if I subtract 2, that means I can make 11 triangles with that shape. And each triangle is 180 degrees, so they just did 11 times 180, and that gave them their answer. That's it, right? That's all they want to know. They just want to know what is the total of all the inside angles of the shape, okay? Now, eventually you'll do more with that. Like they might ask you on a question, how much would each individual angle be? Well, if I'm looking at example 1, and instead of just saying what's the total, they said, okay, what is each individual angle? Well, if the total is 1,980 and there's 13 sides, how could I figure out how much each individual side would be? If I know the whole thing is 1,980 and there's 13 of them, how do I figure out how much one would be? You just divide, right? So if this question was, if they change it up, because in your assignment there will be questions similar to that, where instead of you just figuring out the total, they'll say how much on a 13-sided shape, what would be the degree angle of just one angle? You would do the same steps here. The only difference would be you would take it one step further and do 1,980 and divide it by 13, and then that would give you whatever that answer is. Okay? Obviously for this specific example they didn't ask that, but there will be questions on your assignment that will ask that. So it's still the same steps. It's just once you've got the total, however many sides that shape has, that's going to tell you each individual angle. All right, so I'll write that here. So each angle. Okay? And I know that there's even some questions where, and it might sound weird, but they'll say like, oh yeah, you have a 13-sided shape. What would be the sum of like 10 of those angles? You still do the same thing here. You figure out how much each individual angle is, and then you just multiply by 10. right? I know that seems weird. Some people were confused because of the wording, so they're like, wait, it says it's 13 sides, but then the answer asks me for just 10 sides. So do I do it for 10 or do I do it for 13? You do all the same steps, right? Imagine you have a 13-sided shape, so that's the total. Then when you divide the total by all 13, that's how much each individual angle is. And so if they only want to know how much it is for 10 of them, you just times 10. If they only wanted to know 4 of them, times 4, right? Once you know each individual angle, then you can multiply or add or whatever by however many they tell you to in the question. Okay, so I know some people on the assignment got confused by that. So hopefully that clarifies it for you. So now I'm going to do this first section of the examples here. So it just says find the sum of the measures of the interior angles of each convex polygon. Now, on the assignment, it does mention to you convex versus concave. So just so we all understand, convex just means that the shape looks like any normal shape where all the angles go outward, right? Like all these. Concave would actually be a shape where, like, let's say you have all these sides like this, and then all of a sudden one angle goes in. That would be concave, right? Convex would be all of them just go like this, right? They're all going outward. Concave is you have these angles and then one angle goes in, and it's something like that, right? So I know that that was on there, and some people didn't know the difference between the two, so there you go. So convex polygon. So if I'm looking at a decagon, who knows how many sides a decagon has? 10, right? If you don't know, I also put on the notes here a whole list of like the prefixes, because some people don't know them. So if you don't know the prefixes, I put them in the notes. You can look at them there. But all you need to know is this is a 10-sided shape, right? So deca means 10. And like we just discussed, all we have to do is figure out how many triangles that makes. So a 10-sided shape, if I take away 2, that means it would have 8 triangles, right? Okay, well, if there's 8 triangles in the shape, each triangle is 180. So 8 times 180 would give me my answer, which is 1,440. Okay? Make sense? Yes, kind of, sort of? Okay? All right, so let's do a bigger number. So we got 16 gon, which sounds like way more confusing, right? It's the same exact steps. 16 gon just means 16 sides. So I say, okay, there's 16 sides, but as we discussed already, the number of sides to the number of triangles is just subtracting 2. So I would just subtract 2, and then I know I'm going to multiply that by 180. Right? So I'm just following the same steps. 16 minus 2 is 14, and then I do 14 times 180. And again, it's big numbers, but you're just typing that in a calculator, so it's not like you're having to manually do this, even though you definitely learned how to do 3 by 2 multiplication in 5th grade. So this is 2,520. And that would be my answer. Okay? So again, really nothing too crazy. You figure out how many sides, take away 2 times 180. Right? You're basically figuring out how many triangles go in the shape, then multiply by the degree of a triangle. So let's do the number 6. So for 35 gon, so for this shape right here, how many triangles would fit in a 35 gon? 33, right? Because again, 35 minus 2 is 33. And if each triangle is 180 degrees, then I just say, okay, cool. 33 times 180 is 5,940. Done. That's it. So it's not anything to overthink. You just need to know how many sides there are, and then from there you can figure out the total of all the angles, right? Not anything too crazy. You just take away 2 times 180. Done. Now, on this next section, you're doing kind of the opposite, right? So they're telling you, hey, if one of the angles is 150, how many sides would that be, right? So you're kind of reverse engineering the equation. So you can see an example like this up here where they said, hey, this interior angle is 120, so find the number of sides. Well, this part right here, 120 in, is basically just saying, okay, well, if I just wanted to know the total of all the angles, if one angle is 120, all the angles are 120. So I would just say 120 times however many sides there are. That gives me my answer. Problem is, obviously, we don't know how many sides there are, which is what you're solving for. And remember, when you solve for a variable, solve for something you don't know, you need an equation. I need something it's equal to. Well, if 120 times all the angles tells me the total, and I know this equation because we just used it a little bit ago, then I can just set those two things equal to each other. Okay? And that's all they did here. They just set them equal to each other and solved the equation. One thing to note, if you don't want to have to do this step every time, technically all they did here was 180 times each of these, which gave you this. You can just start here and say, okay, the number of sides times n equals that. Right? If that makes sense, you can just start there. Or you can start at the top here and do this same step every single question over and over again. I don't care either way. But to me, I would rather just skip straight here. Right? Because I know I'm going to have to do that every time anyways. Once you're there, now it's just a matter of saying, okay, so I subtract 180n on each side, which cancels that out. So now that's where they get negative 60n and negative 360, and from there they just divide by negative 60. Okay, the negatives cancel, 60s cancel, that's where they get n. Those negatives cancel, 360 divided by 60 is 6. Okay, so it's pretty much just all algebra at that point. You're just setting up the equation. Okay, so let's look at an example. So 150, that is just one angle. They want to know how many sides it would be. Well, again, if one angle is 150 and I wanted to know the total of all the angles, it would just be 150 times the number of angles, right? Well, I also know, like we just said, that the total of all the angles is subtract 2 times 180. So I'm going to get this 180n minus 360. I'm going to write it out for this first one. So n minus 2 times 180. Okay. And again, I would distribute this to each one. So I get 150n equals 180 times n, which is 180n. 180 times negative 2, which is where they get minus 360. And then from here, again, this is just algebra. You're just solving the equation for n. Okay? So subtract 180n on both sides. That gives me negative 30n equals negative 360. And then just like the last one, we divide to get rid of that. So we get n equals 12. And that would be your answer. Okay. So again, that one's a little bit more math, obviously, than those previous ones. But it's really nothing really that crazy. It's 95% algebra. Really, the only geometry you did there was knowing that you multiply 150 times n. And then knowing the right side is the whole n minus 2. Now, for other questions, I can skip straight to here, right? There's really no reason to do this step if I know it's just going to result in the same thing. So like when I do I'll do number 11. Thank you. So when I do number 11, all I'm going to do is start off with 144n, right? Because it's 144 times however many sides, equals, and then I just put this, 180n minus 360. So 180n minus 360. And all I do from here is solve equations like you do in algebra. All right, so subtract 180n, subtract 180n. That gives me negative 36n equals, whoops, that is negative 360. And then I just divide by negative 36 on each side. So the negatives cancel, those cancel, so I get n equals 10. And that's my answer. Make sense? Yeah? Cool. Now, this last question, there is, I think, like 2 questions similar to it on the assignment. It's technically just tying in what you did for both of these. And it's really, like, I know that when you look at this, it probably looks really complicated, and you're like, oh my goodness, what am I going to do? This, like, looks crazy complicated. I agree, it does look crazy, but it's really not that hard. You're basically just saying, okay, find x. I know that there's 5 angles on here because it's 5 sides, okay? So I know that all I need to figure out is what's the total of all those angles, and I can make an equation, because I know if I add all those angles together, it's going to equal whatever the total is. Well, we just figured out in the very beginning, when I want to figure out the total of a shape, I just take the number of sides minus 2 times 180. Well, how many sides does this shape have? It doesn't look like a normal one, but that is just a pentagon, right? It's 5 sides. It's just irregular. It doesn't look like this, nice, pretty looking pentagon, but it's still a pentagon, which means it's 3 triangles, so 540 degrees. So I'm going to write that on the inside of this shape. So this is 540 degrees in total. So since I want to solve for x, I know that if I take this shape and I just add all of those angles together, right, that means each angle, I'm just going to add and combine like terms, and that should be set equal to 540. Now this is going to look kind of crazy at first. So 540 is the total. And then I'm just going to add angle A, B, C, D, and E together. So angle A is 4x plus 10. B is 6x plus 10. C is 5x minus 5. D is 4x plus 5. And E is just 7x. Now, for me personally, if I'm solving this, I wouldn't write this whole thing out. Right, I know I'm just going to combine like terms. I probably would have just been like, okay, combine all the x's together, and then go in and combine all of the constants together. So if you wanted to do it that way, you definitely could. I personally would not want to just write that whole thing out because I'm just going to combine them down anyways. But that's up to you. But for this, I would combine my like terms. So all my x's would go together. Okay, so these are all my x values. I forgot the pluses in front. So all of them are positive, so that's relatively easy. So this is still 540. So I got 4 plus 6, so that's 10, plus 5 is 15, plus 4 is 19, plus 7 is 26. So I get 26 x's. And then I just combine all the constants. So plus 10, so that's 20. 20 minus 5 is 15. 15 plus 5, basically those just cancel each other out, so that's back to plus 20. All right, that looks way easier to deal with, right? So it looked crazy up here, but really, that's all you're doing, is that right there. And this, you should be able to solve, right? Because again, that's just algebra. This is really straightforward solving for x. That's it. So what would I do first if I'm solving this equation, Blake? What would be my first step? Thanks, Blake. I know. Minus 20. Okay, so I subtract 20 on each side. I get 520 equals 26x. So now, Blake, now what would I do? Yeah. Very good. Now I just divide by 26. Okay, and again, no one's expecting you to know what 520 divided by 26 is off the top of your head. Just type that in a calculator, right? 520 divided by 26, and you get 20. So my answer is just x equals 20. And that's all I wanted to know. One thing I do want to note, on your assignment, they do have questions similar to this, but be careful because instead of saying find the value of x, it might say like find the value of angle A, right? So you still would do all the same steps. You would figure out that x is 20, but then you would have to go and plug x is 20 into that one. So I would end up doing like 4 times 20 plus 10. Or if it was asking for angle C, I'd do 5 times 20 minus 5 or whatever, right? So that's something that I know there was some people that had that question similar to that. So just read the question. If it says find x, then boom, you'd be done. But if it says find like angle D, then I would need to actually plug in 20 for x and solve it. All right, now the back side of this is going to be Backside of this, honestly, most people think that I'm trying to like trick them when I do this one, but I'm not. So this is a triangle. I'm going to just assume this is an equilateral triangle, right? Equilateral triangle means they're all 60 degrees. So if I drew exterior angles for these, that just means I would basically extend this line and go a little bit further out, right? So that would go here. Then I would have like this one, which would go like this. And this one here would go like this. Okay, so let's say I just extend all those lines and it looks something like this. If I wanted to know what this exterior angle is, okay, then that just means all I need to really remember is, okay, well, this whole thing is a straight line. So what is the total degree of that straight line? A straight line is how many degrees? 180, right? So the whole thing is 180. The part that I have right here, I already know is 60. So how could I find this other section here that's on the outside? What would I do to solve for the outside angle? Anyone at all? How would I solve for the outside angle?
Oh, 180.
Right, I just do 180 minus 60, right? Which gives me 120. Okay, well, if that one's 120, what do you think the outside is for this one? 120. They're the same thing on a straight line with a 60-degree angle, which means this is also 120. So effectively, if I'm looking at just the exterior angles of this triangle, I would have 120 plus 120 plus 120, right? Or I could just say 120 times 3. Well, what's 120 times 3? 360, right? So that's the total of the exterior angles of a triangle, right? 360. Well, let's try the same thing with a square. Well, a square, what is the degree angle for the corners of a square? All the angles of a square are what?
90.
They're 90-degree angles. This is right angles here. Here, 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 and here. They're all 90-degree angles, right? So, on that note, if I draw my exterior angles, I would just basically draw these lines that kind of extend out beyond here, right? So knowing that this is 90, and also knowing, like what we mentioned before, the whole thing is 180, what is this angle going to be here on the inside? Or on the outside, sorry. This is also 90, right? They're both 90-degree angles, right? Which means over here, 90, over here, 90, and up here, 90, right? So if I added all those up, 90 plus 90 plus 90 plus 90, I could also, again, just multiply, instead of adding the same thing over and over, I could just multiply by 4. What would 90 times 4 be? 360. Right? So the triangle was 360. The square was 360. What do you think I'm going to get if I was to do a pentagon? Yeah, shocker. I'm going to get 360 degrees. What if I did a shape that has 50 sides? How much do you think the exterior angles are going to add up to? Yeah, shocker again. It's still 360. Okay? So that's what they're talking about here, this exterior angle sum theorem. No matter what the shape is, the sum of the exterior angles of any convex polygon is just 360. All right, so as long as it's a shape like this where it's just all angles going outwards like that, it's just going to total up to 360. It doesn't matter how many sides it is, right? It's just 360 degrees. Okay? Now, on that note, and that's what they mentioned here, right? So I know that this hexagon is 360, right? They already said that. But if they asked me, oh, okay, so the hexagon, you know it's 360, but how would I figure out how much each individual angle is? Well, there's 6 angles, right? So if there's 6 angles, all I would have to do is divide by 6. And voila, there's my answer. That's it. That's all you have to do. Okay? So, for example, on number 1, they just want to know the sum of the measures of the exterior angles. So if it's a decagon and it has 10 sides, what's the sum of all the outside angles going to be? Wow, that was so difficult. Yay, it's 360. Now we're going to up the ante here and go to a 16 gon. Now what's the sum of the exterior angles? Oh, dang. It's still just 360. Fine. What if we go to 36? So now it's like some crazy number of sides. Now what's the exterior going to add up to? Yeah, shocker of the century. It's also 360, right? All of them, no matter how many sides, it's just 360. Okay, so that's one thing to just keep in mind. When they talk about the sum of the exterior, it's always just 360. Now on the flip side of that, they will oftentimes ask you to measure each individual angle. So kind of like what we did on the front, right? When they said each individual angle, we just divided. You do the same thing here. If it's a 12 gon, again, I know the total of a 12 gon is just 360 degrees, but now it's 360 degrees split over 12 angles, which means each angle is 30 degrees. And that's it. I can even go and up the ante to a 40 gon. Still 360 degrees, but now it's just spread over 40 angles, and guess what? That's just 9 degrees. Let's say I go to a dodecagon. Anyone know what a dodecagon, how many sides that is?
12.
It's 12. Deca means 10, do means 2. Put them together, 12. We already did 12 gon, so I don't need to do that again. What about a heptagon? Anyone know how many sides a heptagon has? It is 7. Okay, which means I would do 360 divided by 7. This one actually won't give you a nice pretty number because when I type 360 divided by 7, I get a decimal. So this one's 51.4 degrees. I don't think you'll have any like that. I think most of the ones on your assignment just give you whole numbers. But if they don't, obviously just round to whatever place value it says in the question. Okay, that's pretty much it. So y'all can start on your assignment. One thing that I do want to remind people, this is from a previous unit, but I know that there's questions like this. On the questions where they have you draw a triangle and it says it's extended out like this, you need to draw this triangle. Once you label it, remember, whatever these two angles are here, so A and B, and they tell you that this is X, the exterior angle here, X, is just A plus B. Okay, so whenever you have question, if you have one, some people got lucky. Theirs were just all three inside angles. But if you have one where it says, here's triangle ABC, and it extends out to some other point, right? That means that you just add those two inside ones together, and it equals the outside one, and that solves for X. And again, please remember to read the question. If it says solve for X, then yeah, sure, you'd be done there. But if it doesn't say solve for X, you might have to actually plug X in to get whatever answer they want from you. And that's it.